Hello, thanks for coming back, everyone. My name's Joel. I work at the Linux Technology Center, which is a part of IBM that does open source things for all kinds of IBM products and things that aren't products as well. We work on within open source communities to enable technologies. I'm based down in Australia with my colleagues Jeremy and Stuart. And there's about 25 of us down there that work on different parts of the Linux and firmware stack for IBM.
You call it full stack development?
Full stack, yes, from the first instruction all the way up until when you want to run some user space code. No, and we do user space. So I've worked a bit on various parts of the stack in my time at IBM. At the moment, I maintain the kernel for OpenBMC, as well as the kernel for OpenPOWER Petty Boot environment, the Petty kernel, and do a little bit here and there in all other kinds of areas. I actually can't see what's up there. So, what's a BMC? We've already gone through this. It's not a cyclist. It's a motherboard thing. We're all pretty familiar with what BMCs, and because Andrew's already gone through it, I don't think we need to go through this again. Maybe something that we didn't touch on before is that there's different kinds of BMC stacks that are out there, and different companies give them different names. IBM calls it an FSP, Dell called it DRAC, HP called it ILO. It's generally some small kind of ARM computer, although back in the day it was a Hitachi H8S, running Linux and some kind of user space that lets you interact with it and record information. The functions. So, as I said before, a bunch of different fan monitoring, sensor monitoring, logging inventory, network connectivity, and different kinds of interfaces. And that's where we start caring about what the kernel's up to. IPMI, we had to write some kernel drivers to talk IPMI, and the IPMI maintainer said, no, we've already got that. And we had to explain to him, no, we're on the other side of the IPMI interface, the BT interface. And so that's been a constant challenge in doing kernel things, is that the kernels had a long history of operating on the other side of the firmware divide. We are now the firmware over there.
Is that because people know everything working in dev man and they use space on proprietary BMC?
Yeah, there's a bit of that. So something that's happened a lot in OpenBMC land is trying to write kernel drivers that control the various hardware blocks inside the BMC and exposing interfaces to user space instead of just letting user space do what it wants. If you studied computer science at college, at university, you'd have learned that mutual exclusion and ordering of accesses are important things. And so by having kernel interfaces, we get to do that. So it's almost like a modern operating system from the 70s. So back in my involvement with OpenBMC started with the very first OpenPOWER machine. This is quite relevant to this audience. So the first OpenPOWER machine that we brought up was called Palmetto. Excuse my pronunciation. And it was a Power 8 single socket server that had an ASpeed 2400 BMC. And initially, all it needed to do was send a few commands over IPMI BT. Things like, please turn the machine off, please turn the machine on, and a little bit of logging, I think was all we did. So it was quite simple. And my job was to implement the host firmware sides. This was in SkiBoot. For those familiar with the OpenPOWER boot stack, we had to send these IPMI BT messages down to the BMC. And it was a challenge. The BMC firmware didn't do what it was supposed to sometimes. The IPMI spec is fun reading as well. And so we had all these challenges we had to kind of overcome. And we started wondering that maybe things could be a little bit better. And that's where OpenBMC came along. So as Andrew said, it started off as a project at Facebook. And then IBM did their own version of it in collaboration with Rackspace to build the Barreleye machine as kind of a quick proof of concept that this could be done. And then that expanded into building Zaius with Google and the Witherspoon machine that IBM built for the IBM government supercomputer. And along the way, a whole heap of other people have done various OpenBMC things. We've got some people from Yadro here, which is great. We've got some people from Facebook, IBMers, of course, and I'm sure there's other you in the room I haven't met yet from various other organizations that I'm looking forward to meet. And the project itself, it's incorporated under the Linux Foundation with a bunch of founding members. There's also a bunch of other people who've submitted a lot of code, and as a developer, that's what I care about. We've also got support from both the major white box silicon vendors that do BMC firmware, so that's ASpeed and Nuvoton. So OpenBMC, I'm going to skip over this slide. The only thing that maybe I'll add to what Andrew spoke about is that our user space has the nickname Phosphor. That name is used throughout, and there's a story behind it. Come talk to me at lunchtime. It's not that interesting, but I just can't remember the details. Something about a fish. And so when my involvement in the project started with, what do we use for a kernel? ASpeed do provide an SDK that they've been maintaining over a number of years. It's got all the battle scars of a code base that's supported a whole heap of generations of systems on chips, and is supported by one lovely gentleman in Taiwan. So we took his code base and had a look at it and decided that in order to upstream this code, which is what we do at the LTC, we probably were better off starting from scratch. And so that's what we did. That's what I just described. So the way you do an ARM upstream kernel port in the modern Linux kernel world is you add a device tree, you write some drivers, and maybe you have a little bit of Arch code, but hopefully you don't. And in the ASpeed case, we don't. So if you look in Arch ARM ASpeed, there's a make file and a kconfig file, but there's no actually C code, no headers, no anything. And that's because we use the device tree to configure all the different drivers that the kernel makes available. And the reason the Linux kernel went to this is that lots of system on chips contain IP that's licensed from IP vendors. And so there might be an ASpeed SOC and an XP SOC and a Broadcom SOC. They all have the same network card, but they've gone and re-implemented the drivers 3 times over. And so the ARM Linux community decided to move those drivers out of the architecture part of the tree and put them into the common driver part. Share the common bits of code where you need a quirk because this vendor put an extra register there or different clock setting over here. That's what we use the device tree for. So that's where we've gone with the ASpeed port and now with the Nuvoton port. This was the first commit a couple of years ago now at the ASpeed machine, and this was the 2400, and now we've got the 2500 in there as well. So since then, there's been a lot of code gone upstream. One of the challenges in this model of having the drivers split out across the kernel is each subsystem in the kernel has a different maintainer, and Linux kernel maintenance is in the news at the moment, but it's a quirky community of lots of different people's opinions, and one maintainer will run their tree in a certain way, and another person will have a completely different way of doing it. And so one of the challenges is getting the code upstream is learning to deal with the development workflows that each of these subsystems have, and getting your code past code review and into the tree. And we've touched a lot of subsystems. That's not all the subsystems in the kernel, but Watchdog, I2C, HWMon, IO, network, MTD, clock, the MIST directory for all those other bits that don't fit everywhere else, IPMI, USB, DRM, which is the display driver. We added our own subsystem called FSI, which is IBM's protocol for reaching into the processor and doing kind of JTAG-y style things. We also wrote an NCSI library. So NCSI is the ability that BMCs have to share the network card between the host and the BMC. So different MAC addresses, but same physical interface. That kind of blew my mind when I first learnt about it. It mostly works. Yeah. And so one of our other big contributions in the networking space was my colleague Ben rewrote the network driver, and we went from a couple of megabytes a second to maxing out the line speed of the network device. So everyone in the kernel community has benefited from that, not just ASpeed, because this bit of IP happens to be very similar to one from Faraday Tech. So that was a good contribution we made.
Which machine has this NCSI?
All of the OpenPOWER ones use NCSI. there's different, so so ASpeed has two Macs, two mid-access grills, and they can be wired up directly to a PHY, so a dedicated kind of normal style network device, or it can talk to NCSI to a NIC that is shared with the host. And all the Google machine, Zayas has the configurability to be able to have dedicated or NCSI. It uses a HDMI connector and it's all crazy. Lots of flexibility in Zayas because that was designed for both Google's requirements but also the OpenCompute Barrel I2 machine. And so that one's quite flexible. Most of the OpenPOWER machines use NCSI for the a Broadcom in all cases. Yeah. No comment. Sorry. We don't implement any in the OpenPOWER machines, but I literally just act a patch. So there's some people from Intel who are Dell who are interested in OEM commands for Mellanox, I'm going to say. And there's also people from Facebook submitting patches as well. And so our NCSI maintainer, Sam Mendoza-Jonas, my colleague down in Australia, he's coming up with the way to handle that. What we're going to end up with is a little bit of in-kernel code to do OEM commands, things like retrieving the MAC address. It makes sense to do in the kernel because then the device can come up with the correct MAC address without involving user space. For trickier things, we'll probably expose a netlink interface to user space, and so you can write some user space code to query the NCSI commands. I know that NCSI is used for all kinds of things beyond what it was originally perhaps intended for, and so we intend to support all the use cases. It would be really good if people could contribute to that discussion in saying, we plan on doing temperature sensors or firmware updates or whatever, and so we can design the APIs appropriately. But yeah, to date, the OpenPOWER machines haven't had to use it. So we store it in the U-boot environment, which has its challenge. I mean, for development, it's quite frustrating because if you flash a complete new image, you've lost your U-boot environments, you've lost your MAC address. We set it. I mean, it's on a sticker on the board. So if you're physically co-located with the system, you can go read it off. If you're not, you can make up a new one. Sorry? Yeah, it should also be in the VPD for machines that have gone through manufacture. I guess I have a very skewed perspective because I work on pre-production development machines. But yeah, I think in production it would come from the VPD. And the VPD gets mirrored into the U-boot environment and it goes from there. It would be much better to use NCSI. Well, I guess it's putting it in a different place. It's putting it in the network cards VPD instead of the planers VPD. But yeah, that's something that maybe we can kind of create consensus on with OpenBMC and saying, going forward designs should have this because it's convenient for our purposes. So NCSI, I spoke about many masters in kernel maintenance with varying availabilities and rules and whatnot. Very strong views of what the subsystem represents. We're still having that discussion around our OCC HWMON interface. And yeah, as I mentioned before, writing the BMC side drivers, having to convince the maintainers that this driver is necessary because we're the other end of that interface that the existing driver is talking to. So this talk was pitched as a bit of a indication of how we've managed to do a fair bit of good collaboration in the kernel community in OpenBMC. That's also extended way into the user space side since I proposed this talk. There's a lot of collaboration going between different companies and vendors pushing stuff into the Yocto tree, which is great. But the kernel was the first place where we started kind of collaborating a bit. So that wasn't updated from the last time I gave this talk. We moved to 4.18 about 6 weeks ago, and I pushed the stable trees to the stable kernel trees to the OpenBMC repository whenever they come out. Got a question at the back?
Just curious, because there's so much work going on and being pushed into Yocto, is this project probably one of the leading projects in terms of what's pushed into Yocto right now, or is there other projects
I don't work on Yocto. As far as OpenBMC project pushing stuff upstream into Yocto, there's a small amount, but not a huge amount. We're mostly a downstream consumer of Yocto, so we use Yocto, and we've created a bunch of layers on top that other people could use for different purposes. For instance, at the moment, it's all pretty OpenBMC centric, but there was a big re-architecture in the OpenBMC user space world a couple of weeks ago, where we split out all the sub-layers into their own repositories. And there's some intent there to, for instance, the BSP layers for the Nuvoton and the ASpeed, to upstream them to open embedded, so that someone wanting to build a system on those chips that wasn't necessarily calling it OpenBMC would have that flexibility. Yeah, does that answer your question?
Yeah.
So one of my goals is to make that bar graph go to 0. I don't want to be the OpenBMC kernel maintainer forever. More importantly, I don't want to maintain any patches. And we're doing a pretty good job. There was a lot of code that we shipped on the first few machines that were out of tree, and now, depending on your system architecture, you could probably get away without any out of tree patches. The OpenPOWER machines have a few, mostly that OCC thing I was talking about. The other big one is the GPU driver that I haven't upstreamed yet. That's my fault. I need to stop coming to conferences and sit in front of my computer instead. And so you can see a little bit of an overview there of what's remaining. So we've got the FSI, we've got the DRM driver, and then a few other little ones off to the side, a few patches in the SPI NOR subsystem that we're struggling to get in through no fault of our trying. So if you know anyone who works on SPI NOR subsystem, come talk to me. I need your help. And USB is all upstream. Yeah. So Ben did that a couple of cycles ago. So the work that Andrew mentioned with enabling virtual media, that went really smoothly because we already had the hardware support present. So I don't have a picture of all the IP blocks inside the ASpeed SOC, but if I did, it would be mostly coloured in indicating the upstream support's there. There are parts that aren't. Intel are pushing pretty hard trying to get a PECI, a PCI system, a subsystem upstream, so that they can use that. I guess that's in x86 world, they have PECI, we have FSI. I think they're kind of equivalent. So that's a big part of the chip that's not upstream. Apart from that, I can't think of any major blocks that aren't there, which is good to see. So I'm kind of preaching to the choir a little bit here, because there's lots of people that I'm actually talking about in this slide in the room. But the code was noticed by people wanting to do their own BMC. The most amusing one for me was the OpenWRT-based BMC, which is, in my mind, it's actually a really good fit. You know, OpenWRT provides a web UI and kind of an embedded Linux kind of environment. So that was an interesting project. Less complicated? Yeah, I'm forbidden from making any comments about Yocto. Come see me at the pub. So yeah, one of the more interesting ones was a community member. He happened to be working for Google, but he was doing this on his own time. His manager bet him that it would take him more than a week to port OpenBMC to a new x86 server. It's this quantum machine that they had, and he got it up within hours and got the machine booting. And so it kind of goes to show that having this strong kernel base allows you to do all kinds of experiments. One of the more interesting experiments that's on the go at the moment is a couple of people from Google writing a BMC stack as a single Go program. Because if you work at Google, you have to re-implement everything in Go. And the upside is that it's got some very specific goals, unlike OpenBMC, which is quite broad and flexible. This is going to solve a bunch of problems, and I'm looking forward to it. So the kernel, as I said, was a good initial rallying point for getting a bit of community going. It's quite obvious how to interact with the kernel processes, as weird as they may be for people that haven't used mailing list to review patches before. And we did manage to get lots of code from different vendors in there initially to get the device trees in and get drivers in, and now, make the system work a little bit better. So that's the last point there about moving away from DevMem. Much to my colleagues, I don't know, they were quite upset when I disabled DevMem in the kernel because it was good for their debugging. On the upside, it means that nothing can be playing around under the covers with the state of the system on chip. And so if you're talking to the hardware, you're doing it through the kernel, and hopefully that results in fewer bugs. So the BMC Silicon vendor, this is the Nuvoton story. They came knocking on the door and said, we need to be an OpenBMC. And I said, okay, you need to upstream your code. And they said, okay. And I thought that was a great thing that we'd established this norm in OpenBMC land, that if you wanted to be part of the project, you got your code in the tree. And so that was about 18 months ago that they first approached us, and the effort's still progressing. These things don't happen overnight, but most of their SOC is now supported upstream, and there's people building machines based on that code base, which is great to see. So the current status, most of it's upstream. Hash and crypto is the last remaining one. If you want to cut your teeth on kernel hacking, come see me and I'll tell you what you need to do. If you want to upstream that one. Nuvoton is in a similar place, lots of support upstream, a few kind of important pieces to go. And then it'll be kind of more case by case, as it was with ASpeed, where some vendor will come along saying, we're using this different part of the SOC, can we please get drivers in for that? There's now 10 machines in the upstream kernel tree. Another Facebook one went in the other day. And we've got all three kind of major CPU architectures represented. No one's built a RISC-V server yet, so we haven't kind of that or anything. But yeah, so these are ARM64, x86, and Power are all kind of represented there. And ASpeed systems can almost boot with upstream kernel. The MBox driver is the only outstanding one. So watch this space. So in the future, what are we going to do? We're going to finish the job. We're going to get that bar graph down to 0. We'll get there really soon, and then the silicon vendors will release a new version of their BMC SOCs, and we'll get to start again. But hopefully we're set up in a good place to support the future versions, because they tend to kind of iterate instead of reinvent the wheel. We want to keep educating vendors to upstream their code where they can. I've already had discussions this morning about that. So if you're worried about it, come talk to any of the OpenBMC team here, talk on the mailing list, jump on the community calls. We're all there to help. And my goal is can we get to the point where, as an end user, I can buy a motherboard off of Amazon or something and update the BMC myself because I know there's a new kernel release out. That would be kind of cool. I mean, that's a different end goal to maybe our hyperscale data center kind of customers. They've got different goals in mind, but as a hardware enthusiast, I'd like to be able to do that, and I think we're getting pretty close there. So that's all the prepared material I had. Do we have any more questions? Yep.
So you mentioned in the last point where you want people to move from kernel to kernel. In that case, what kind of testing that can ensure that all stuff is there?
Right, that we haven't broken anything in the new release, like we did recently. Yeah, UBI was broken. The UBI maintainer broke UBI, extended attributes. Yeah, I mean, so we caught it pretty quickly. But I do all my testing on Romulus and Palmetto, the P8 and the P9 reference platforms. And this bug was only exposed by Witherspoon, so that didn't happen. And again, that's only the OpenPOWER systems. We've also got the people, Facebook working on all their systems, the Intel people, the Dell people, the et cetera, et cetera. And we haven't got an answer yet for how to do that kind of regression testing. Oh, actually, here's one I prepared earlier. QEMU is a great tool. We've spent a non-trivial amount of time, when I say we, I mean Cedric, getting the ASpeed SOC well-modeled upstream. And it's quite a unique thing, actually. There's a whole heap of different platforms modeled in QEMU, but having extensive support for a single system on chip such that we can test most of the kernel drivers is actually really cool. And so that's kind of in some ways that's the hard bit, writing these models. QEMU's a steep learning curve. The rest of the work that needs to be done is setting up some kind of continuous integration where we grab Linux Next, we grab QEMU, we build a variety of different images that use different parts of the kernel functionality and run that through a kind of regression test. At the moment, yeah, the testing is simply me doing a bunch of tests, booting machines I've got. I then put it into Gerrit, the kernel bump into Gerrit, and that'll go through Andrew's hardware CI, so it will boot on a Witherspoon platform when it's enabled. Yep. And so we get some kind of validation there, but you know, the UBI regression only showed up when you tried to modify a file, and it would fail in a really weird way. So we didn't catch it in CI, so it went into the tree, and it took some debugging before.
We did add a test to CI now.
Yeah. Yes.
You gotta learn.
Yeah. The risk in moving forward will go down over time as the drivers become more stable. I know that your colleagues at Facebook have been going through a bunch of the drivers with a fine-tooth comb and finding some, not necessarily bugs, but just things where the code wasn't quite right. And so as we do that further testing, it's going to get better. Yeah.
That particular bug they found that to raise in test case, simple test cases.
Yeah. So
Where do we add those test cases into some kind of bundle there?
yeah, I would be very happy to run that bundle. And so I'll start a discussion on the mailing list. So thanks for that point. There's
I guess the question is how can we get your machines into the CI?
I'm sorry, my question is pretty much like, say you change the driver, like one bug,
Yes.
you have a test case like in the C.
Sure.
Run it. How would I run that test case continuously? If you have correct those kind of test cases continuously, you can just have that bundle list. You can run continuously, see like what happens. It takes.
yeah. So
OpenBMC has an OpenBMC test repo, which based on the robot framework, that has a ton of regression tests that, will run for hours and hours and hours.
But that's for the platform test, right?
That is a platform, it's an OpenBMC on a system site.
Yeah.
That was only for kernel, let's say.
right. Yeah. So that's a question that I can answer. The kernel has a bunch of self-tests in the upstream kernel tree that are designed to be run against a running kernel. Lots of them are testing the way the APIs work and system call interfaces and that, testing things like the timer bug that we recently had that probably requires running on hardware. I'm not sure. Do we put them in self-tests?
I mean, it's a pretty brain installation of things.
We could start doing it.
Things that might be in fact testing the hardware. So that's
Yeah, so in this case, we weren't programming the timers correctly, and so the scheduler wasn't scheduling properly, and tasks that were meant to run for a defined amount of time were running for way longer than they should have. We could try putting in self-tests, and if someone says no, we'll put it somewhere else. So part of the problem is putting in self-tests, the other half is running it. But to the point that Andrew and Jeremy were trying to make, it would be great to get more machines in our hardware CI pool, and that would probably involve coming up with a way that you could easily grab the latest commits and run some kind of tests and then push a result back to a central repository. And even if this was only best effort, we logged, oh look, Facebook did a run of tests on Friday and it all passed, or we had these 3 failures, let's bisect that failure and work out what went wrong. It would be great to get some kind of something like that in place. Because I know that the x86 machines are fairly different to the power machines in terms of what functionality they exercise and whatnot. So yeah, let's talk.
Yeah, I guess it didn't really touch on that. I mean, the acronym's pretty open for different acronyms.
You can ask the questions now if you want to talk about it now.
Pretty much like say, you mentioned like 7 different platforms, right? Is there some kind of variety of systems where you run them continuously, like for CA, you have to create the images for all these 7 platforms, run them on the physical machines.
Yeah, I think CI we only do like 5 systems right now, right?
5 systems.
Yeah, there's only a
Hey,
few.
Sai, what was the question?
I'm still asking.
I'll repeat it once we've.
Okay.
Yeah.
The continuous integration, like when you create the images, like 5 systems you are running, are those like, is it within IBM framework or like can it be open source?
It's open source. So the question was, we currently have CI for the project that does a build on the Jenkins instance, and then it's tested. Some of those images are then tested. How's that work? The machine itself that it runs on is a VM donated by Rackspace. The Linux install is maintained by myself. The Jenkins side of it is maintained by Andrew. All the configurations on GitHub. We're not really limited by compute. We've got a couple of big build slaves from Google. We've got a couple of big build slaves from Splitter Desktop, and one other one somewhere else. Oh, that's the IBM one, the soft layer one. So there's a fair amount of compute there. We absorb a lot of it for doing builds because Yocto is compute heavy for doing builds. So maybe if we had some more machines that could run QEMU instances with the images in it, we could do more testing.
Yeah. Right now we just take the Romulus, that's kind of our reference system, and we run that through QEMU. So every CI job will do a QEMU run.
Not on the real hardware, right?
Well, if that passes, then we do a real hardware run on the IBM Witherspoon system. That's internal. But the data is kind of like what Joel's talking about. We will say, hey, it failed, right? That's all you really get. And then you got to contact somebody. And it's really our job to say, hey, you put a commit in, it failed on our hardware, here's what happened. So that's kind of what we'd like to see other companies do, right? Is run those same tests on their hardware, and if something fails, say, hey, this worked.
Yeah. So yeah, the first instance, it'd be great to see more. Once the machines are in the upstream tree, I'm happy to enable them on OpenPOWER.xyz for the builds. To the point, if we end up with 30 more, then maybe we'll have to reconsider, or at least we'll have to shard out our builds.
How do we scale this one, like say, beyond like 5 or 6 or 10?
Yeah, and I think that we need to set up some infrastructure that lets people report how builds are going. I've always had this idea that, at least initially, it could have been a manual thing where there's a web UI, you log in, you just click the green button to say, I did a build on this and it worked. We want to automate that, of course, but at least at the point when the project was 5 of us, that was a useful thing we had. We were kind of doing it on instant messaging. Oh yeah, I ran today's build, it didn't break my system. Or today's build broke my system, don't run it. And so having something automated that reports test results would be great. Yeah, it's mostly a matter of manpower, I think.
So
having
Joel,
some time.
Do you envision that after that, as part of this CI effort, that you'll actually run it on the target machine, on the hardware?
I think we want to push that out to the people that own the hardware. So if you're a company making a machine and you've got your OpenBMC code in the tree, at least initially it'll be up to you to run it on that. What we want to do as kind of the OpenBMC community is provide a mechanism for hooking up this build. It might be as simple as running a Jenkins slave, but that requires you to have a public IP that someone can SSH into. So sometimes you need a more complicated setup where the internal CI is sitting there reading from the repository, doing builds, and then it reports up when something goes wrong, or even when it succeeds, actually. You want to report both instances.
There's a couple of different models there, right? So OpenStack does sort of a dual thing where they have a bunch of their own infrastructure as OpenStack, and then you have other people contribute CI farms that send results up. And some of those can become gating if they're reliable enough. But hopefully OpenBMC gets to that scale as well, so there will be that many vendors making that many machines and that many people wanting to put things in. But I think, it depends on the model one, probably start out on.
But there's a
machines that they want to run it, do they have to be firewalled off, or can they be somewhere accessible? And what do we have to do to reset the state of the machine, right? Because there's state in the machine that isn't, reset when you reboot the BMC necessarily. So we might need sort of then how control to actually, automatically make things better on some machines more than others, depending on it. So I'm guessing it's going to evolve depending on who jumps up first and says, please, I want all my hardware to run all the regression tests.
Yeah, so there's a few kind of projects around the kernel, on kind of kernelci.org, I think, and that's where you can make a machine available, and once it gets hooked into that infrastructure, it'll log into your machine, run some tests, boot a kernel, suck the results back out and put them up somewhere. So I think what you've identified is we want to do that. It's just kind of how we make it happen.
Someone set it up and
Yeah.
If it's just like a machine on the network, like a public IP, is that all we need to kind of make it happen? Like each company has their own platforms on a public IP.
As long as nothing goes wrong. One of the challenges, if it doesn't boot, you need serial hooked up so you can get serial out. If, like Stuart said, if there's some implicit state from the previous version of the firmware in the hardware and you haven't done a power cycle, then you're not really testing. But likewise, you kind of want to test without power cycling because that has different results. This was a huge problem in porting OpenBMC to Palmetto. So Palmetto originally shipped with a different BMC load, and we were bringing it up on Palmetto. And I spent days doing bisection runs that were invalid because when you reboot the A-speed, it doesn't reset. And so there was state in there that made it work. If you power cycled, it didn't work, and things like this. But yeah, best, we can go for the best golden CI, or we can do something that just works to start. And so maybe initially we could just get something that works, get the booting, and it depends how much it breaks, I guess. If it breaks on a daily basis, then we'll need something more robust, because if it breaks, it means someone has to go in there and manually reboot the machine. But if it works for the most part, then maybe that's okay. Yeah. Yeah, so Cedric said we could initially try net booting OpenBMC, and depending on what you're testing, that will provide coverage over a bunch of the code. Obviously, it won't test things like UBI, but it would test other drivers and interactions in user space with the host BIOS and things like that.
I have a question. You removed the dead guy.
That's not a question, that's an accusation.
So I understand why, obviously, that it proved to be really useful recently, that the React issue we found really good. Yeah, that was really useful to be able to look at the internal registers of some devices. So what are we thinking of for replacing this?
Yeah, I think having the most obvious solution to me is we make devmem be a kernel parameter. So get this code upstream. Make it so that you can provide, enable devmem on the uboot command line. And so I envisage that a production machine will not allow anyone to change the uboot environment variables, so they can't change the command line. But for developers, we could set that and go about our way. Does that sound all right?
Yeah, because I think we need some kind of on the field, not for the, but we need some kind of way to.
Yeah, I was hoping that by turning it off, someone would get annoyed enough and solve the problem. But yeah, no one has yet.
Do what we do for the host, another processor off to the side.
That's what the coal fire is, right? So the slide I had up before about QEMU. Should I talk about that now? Or do we have a dedicated section on QEMU?
Yeah. I was going to do a demo. I don't know if you guys want to launch it up and show it.
Cedric really should. Oh yeah, expert mode is what Cedric's been up to. So this is, your name's on there as well, that's good of me. This is, who's familiar with QEMU? Show of hands? Yes, pretty much everyone. So QEMU is a system simulator, kind of. It's used for two major use cases. One is running KVM virtual machines, so the Linux kernel virtual machines. The other one is emulating all kinds of different hardware. So it can emulate the instruction set, but also the peripheral space. And most of the work that we've done, that Cedric's done, has been writing models for the peripherals that's inside the A-speed SOC. And so we support networking, I2C, the flash access, etc. And we can take a kernel and a device tree, which is what this command line here is doing. We can also take a full flash image and boot that inside QEMU. Not all of OpenBMC works because it needs to talk to devices that are present on the rest of the motherboard or present inside the host processor, and they're obviously not present here. Cedric has been working to solve that by connecting a PowerPC and an ARM QEMU together and simulating the entire show. There's lots of things that would involve to get everything working, but it's definitely possible that we could have kind of a subset of code coverage testing there. And that's not to say that someone couldn't either mock out more of the peripherals accesses or change the user space so that user space didn't require maybe having a dummy host object that it could operate on and it could go through all the state transitions to make sure that it got to the ready state and the power on state and whatnot. So that's kind of an open project for anyone. As Andrew mentioned, we currently use the Romulus model to boot the Romulus image and check that works. You could definitely take your random platform, a Yadro machine or whatever, and image and boot that, and it will work because all the things are in the same places. The only real difference between the models is where we attach I2C devices and the amount of RAM and flash chips, kind of these platform differences. But in general, you could use Romulus or the EVB to boot any old machine. And so we've got 2500 and 2400 in the upstream tree. If you're running a recent enough Linux distribution, you can apt-get install or yum install and just use that one. But if you want all the shiny new pieces, clone Cedric's tree from GitHub, and off you go. I can demo. So when I do kernel development, actually I can't see what's up there. When I do kernel development, this is a really quick way for me to verify that I haven't broken things. I'm just getting set up. Excuse me one moment.
Definitely using QEMU became a requirement after, we were just going right to hardware. We kept breaking systems, right? We really need to make sure. So this has to pass before we run on the hardware. That helps a whole lot.
Yeah, running on hardware actually can be a bit of a job creation of people to go in and reset the hardware and pop flash chips.
Very happy with it.
I find it's best when it's on machines on the other side of the world and you have to wait like 12 hours for someone to show up.
What are we, 5? Oh, I really can't see that. Yeah. So here's one I prepared earlier. So you can see here we're booting U-boot, and then it's loading the kernel from emulated flash, and the device tree, and the init ID, and the kernel starts. Takes a while to decompress because it's a bit slow in the emulation.
Well, actually, it's faster than on emulation than on the AST
2400, yeah, 2400 is slow.
Yeah, the whole time
and we found bugs in QEMU that were not showing on the hardware, which was faster.
Yeah, yeah.
it's not a potato.
So here it goes. It's getting there. Hey, look, it's OpenBMC. Anyone know what the password is?
For a loading prompt, it's perfect.
So you can, oops. Looks like a real system. What else can we do?
Maybe do Control-F. Kind of see the different services. This is all the system D stuff. Right?
Yeah, I love waiting for this. This is my favorite part of my job.
This is the BMC standby target, right?
And we're done. And so this is actually a figure of merit that I keep my eye on and make sure I haven't broken anything in the kernel. So we take about 7 or 8 seconds to boot, and if that goes up a lot, I've done something wrong. I recently opened a ticket on GitHub for us to look at making it go a bit faster. There's some things that are a bit hard to go faster, but there's some of our drivers that seem to do a whole heap of not much that maybe we could make go a bit faster. And then, yeah, about a minute and a bit for user space, depending on what's going on and what the previous boot of the system was and things like this.
Yeah, we'll go through and scrub that, and we'll bring it down a bit, and then we'll add some new stuff and go back up. Right now, our biggest mission is to get rid of Python with an OpenBMC. That takes up.
What do you use Python for?
It's getting slower and slower, but like that mapper that I talked about, that's written in Python right now. But we've got a C++ one coming in. There was some old, we called it skeleton, so there was like some system chassis management type stuff. The biggest thing right now is our REST server is, yeah, but we've got a plan, we're moving on to a C++. Yeah, the Python ones are on their way out. Both from, we run out of flash space too on our systems as we keep adding new features from BMC. So
how big is the image today, on the system, like how many?
I mean, we got 32 meg chip to put it in, and our read-only file system was getting up to like 20, and then you got to allocate some writable space. You got each kernel in there, and so it's getting near the 32 meg area. So we've actually got a new phosphor tiny distribution option that I added that reduces the image of your OpenBMC.
It's after compression, right? Without there's no compression for the
That's everything compressed, and that's the raw.
file.
Yes. So the layout we have for OpenBMC Systems is you boot your environment, the kernel with an IRD combined into a DTP, a fit image, and then a read-only file system, SquashFS in Flash, and a read-write file system that's JFFS2 that's overlay mounted on top of the read-only file system. And so this is the largest partition. I can't convert that number of hex bytes into megabytes, but it's about 15 or something. And then a couple of meg left over for the read-write. So the read-write in production would only be used for logs and crash reports. In development, you can put temporary binaries over that kind of replace the one that's in the root file system for development testing and whatnot. Our kernel is currently maxed out. We went to enable a hope of USB drivers and they wouldn't fit. So there's two ways to fix that. Or three ways. One way is to make very machine-specific configurations. At the moment, I try and keep the kernel somewhat generic just because it simplifies the testing matrix. But we could make it so that only the I2C peripherals for that system are built into that kernel. Another way to do it would be to try and make it a bit smaller, disable some features. And then the third way is to get link time optimization going for the kernel, which is very experimental. It's not upstream in the kernel, but potentially we could eliminate a whole code. I'm not sure how much though. The DRM guys seem to think it would make a big. So when we turn on DRM, that blew up the kernel by about a meg of binary size, or 700 kilobytes, a fair amount. Mostly because the DRM subsystem is quite complex, designed to support your fancy, fancy GPUs and whatnot. And we only use a small subset of the API in the ASP chip. But as it turned out, it didn't make it that much smaller in my testing, only like a 0.1% kind of thing. So either something was going wrong or it doesn't actually save that much. I don't completely understand why. So that's on the to-do list. The other option is we could bump the size of the flash layout and take away some of the space from these ones, but that's not ideal.
What compression are you using?
We use XZ for the kernel, and SquashFS uses XZ? Yeah, XZ as well. JFFS2, it's its own file system that does LZO or zlib. Does a little bit of compression on it. Yeah, it's all CPU. No, there's no obvious. I mean, one obvious thing is no, there's not much obvious things. Yeah, put a big flash chip in.
That's what we're going to do.
Have you thought about BMC kind of traditional
Yeah, that would be great if the hardware guys let us do that.
Any platform has it?
No A-speed ones that we're aware of. I think that no, Dell use Nuvoton. I don't think Intel are using EMC on current platforms yet. To me, that would make a lot of sense, especially because in OpenPOWER we kind of abstract away, we virtualize away the host firmware access from the flash chip. So the host firmware is read via a protocol. No, it's not read by talking to the flash chip directly. So if we had one large EMC device, it could contain OpenBMC and the flash image for the host firmware on it. I asked about that in P9 development, and the hardware guys said, no, we don't want to incur that cost. So they said no, which is annoying when it's an $80,000 machine. It's like, come on. So, but yeah, it would. There's no architecture reasons why it wouldn't work. Yeah.
And when you have the dual flash, it's like copying it, both of them same copies, right? For the Romulus.
No, we have different images.
Oh, different images
Yeah.
of the same.
So when somebody uploads a new image, it goes on the other chip, and then when they activate it, it'll use that one. And then, so it's kind of a back and forth. So when we initially ship the system, it's the exact same image in both, right? But
It will go to ping pong, let's say.
yeah, but then after that, it's ping pong back and forth.
Standard and unless one.
Yeah. You know, you could still do a golden image type design where you only ship in one read only, right? So you always have something to go back on. You could do both of them. It's kind of what you want. The way we ship it is.
How does it like when system boots up after power on, it has to boot from, always boots from the first chip, right? It's 50.
Yeah, unless that Watchdog is
Yeah,
right.
watch that, it will then go to the back.
Yeah. But once U-boot comes, then you can say load the image from, or actually once the kernels come, then it's like we'll load the image from this chip to this chip. So that's how things are.
Yeah. So if you had a bad U-boot in your primary flash chip, the Watchdog would buy it, and you'd end up rebooting the other one. As long as the Watchdog's strapped on. Is it strapped on? Maybe that doesn't work.
No,
Have you ever tried that?
I don't know if the testing will watch that. Works like jam.
Andrew promises you it'll always work.
It actually does work. We did this not on our current system, but in my previous job. We had an x86 system that had AST2400, and we used this hardware Watchdog to flash chips, and it was very robustly working.
Yeah, I think that'll definitely work. I'm just thinking about you have to make sure the Watchdog's strapped on, because normally it's turned on by the assembly in U-boot.
You just need to think about it when
In
you
advance.
design your hardware.
Yeah, exactly.
You can actually do it. If you have done that with you,
Uh-huh.
there's a register setting them up.
Yeah, yeah.
By default, I think it's like 22 seconds.
Yeah, the Watchdog time, yeah. Yes, it'll be a long, but yeah. So that's everything I prepared. Any more questions, or what are we going to do next?
Did a demo thing before lunch, I think was the initial thing.
Yeah. So we showed QEMU. I think that was going to be most of the demo. Show the web UI. Show some of the processes that run around this.
Yeah.
This is our CI, and in here, I was just going to show, oops, no, not that. The run, it happens on all machines or only on Romulus for the QEMU testing?
Yeah. Yes. Yeah, because you also see that there.
Which one should I click on? One of these, or click on the output?
I mean, you can just open the port and look at the robot test results. Oh.
No, you have to go.
No, you can't.
Just save the file and then
All right, let's not do that.
browse security.
You don't disable the security feature.
No, why wouldn't we disable security features?
Then it works in your browser. So yeah, we have a couple different jobs. This is the build.
Oh, that's very exciting. Yeah, okay, I won't bother about that. That was maybe a better thing. The web UI.
That would be really nice on OpenPOWER XYZ is to keep some reference images.
Yeah,
Available.
we do. Well, unless Andrew deleted them.
Ask for it, it'd be nice to be able to give them again, to use that 2.05 or that 1.0.
Yeah, we haven't been, as a community, we haven't been good with the tagging, right? So there is a build out there that'll build the tags, but we're what, 400 into our current tag, right? We're just not. But we're gonna fix that. We've got a release planning group now, right? And there's actually, the plan is to follow the Yocto tree. So every 6 months or so, Yocto comes out with the next version. And OpenBMC now is gonna track their releases. The idea.
Can I voice my exception and say we need to do a tag more often than every 6 months?
But that's still only like every 6 months. And
Yeah.
I know there's been discussion on the mailing list about
I tried to start a discussion on the mailing list so that Brad would create a tag, and it got derailed, and it was horrible.
Let's say you create that tag, and then all the platforms will use same version.
Yeah. So the tag in my, I have a platform. Let me use it. What I was thinking the tag could be used for is just a marker in time to say this is an image that is somewhat recent, and it's not necessarily a guarantee that everyone's verified that it does something. It's not a guarantee that certain features are pleasant in the machine. It's something that's easier to read than a SHA. And when you're talking to someone who's got a machine, they can cat the version information out and say, oh, I'm running 2.6, and you know that that's something from this year, not last year. So in my job, that would make everything a lot easier. I know that other people have different kind of objectives in mind for what the version field would represent. It would be great to get some consensus on the mailing list so we get another tag done.
So you use that 2.0, what are the number that you use, 2.0, but when you change something, like you have to 2.1, 2.2,
Yeah, but what does it mean? You know, Yocto is like 2.6 right now, and so our plan is that we're gonna have a 2.6 tag. Right now, I think we're like 2.4 or something. You know, we arbitrarily were choosing numbers, right? It didn't really mean a whole lot. So we're gonna follow them. But along Joel's plan, there's nothing to stop us from having a 2.6.1, right? Where we could have some point releases that fix security bugs, right? Maybe even we have a branch, but all those meta layers within OpenBMC would be following that tag. So you could backport fixes, but not, you still have your master, right? Your brand function. We're still as a community trying to figure out what that is, and if you're interested, definitely the release work group is a place to go. We're discussing that now. We've kind of said we're agreed that we're going to follow Yocto, just because it makes a lot of sense. We have the metal layers, it just fits well. But there's nothing to stop us from having our own little point releases that would give us more granularity.
One thing that version number is currently used for is the IPMI version field. So if we have something that's more than like a couple of bytes, you can't represent it. So that's another problem that needs to be solved.
But why there is no result for Fedora or Kubernetes?
Oh, so yeah, so thank you for volunteering. There used to be a guy that worked with us in our team who was a Fedora hacker. He actually had his own derivative of Fedora that he maintained. What was it called? Chris Smart was the name of the person. The distro was Cora. Yeah. So Chris helped set up the CI, and the reason the CI originally came about was that we kept on breaking it on the other person's distro, and so we had both in there. Chris stopped working with us a while ago, and so no one's maintained it. I think we can probably remove it from the column now, if only because we don't tend to break building another distro anymore. Whichever the latest version of systemd is that's in the latest distro might break something for someone, but in general it stayed pretty stable. Although the wonderful glibc maintainers took a few features out of the headers recently and broke like half of the open source ecosystem. So currently you can't build Yocto on something that's running glibc 2.32. So I imagine that'll be a Fedora rawhide as well as a Ubuntu latest dev version bug. But yeah, no real preference. Most of us in our lab tend to be Debian Ubuntu people, but Yocto will build fine on latest Fedora. I think Stuart, we have a resurgence. There are a bunch of Fedora users now. You use Fedora.
Yeah,
you don't build
Fedora,
OpenBMC.
like desktop stuff on the machines I build on, they tend to run a little bit because they're set up by someone else, and
Which effort?
Calculating the Fedora.
Um,
I mean, my concern would be compute power.
compute power would be the big one.
Yeah.
So if someone donated another couple of big VMs, we could build on both. Yeah.
Fedora project was interested in that.
Yeah. I mean, really, what we should do is remove the Ubuntu tag and just say this is it'll be inside Docker. So in theory, we could just change the scripts to do something else as long as the dependencies were set up. Yeah, nothing against our Fedora friends, Red Hat friends. Am I notified?
Yeah.
I'm just getting the web UI up while we talk. So continue discussing.
So yeah, up here, I mean, when you go back to that main page, there's like, we've got a CI job for the meta layers now. So every time there's a change that comes in for, meta Facebook.
Oh, my notification is from there.
Like we do a full Yocto build for like 3 or 4 systems. And then once that goes through the whole process, it gets merged in that layer, and then the OpenBMC layer picks up that change from the meta layer, right? And that's your kind of official build. We do another full build there of everything. But then all of the individual, software application OpenBMC repos goes through a CI, right? So we've got, most of them use CMake or Automake, and then they've got Google Test for individual tests. We actually have a job that will run that as well for all those different individual repos. So that's kind of the flow. You put it in the individual repo, it gets merged. That goes into the meta layer. You do the full build, that gets merged. Then it goes into that final OpenBMC layer. Goes through another full build, and then that'll go through the QEMU Romulus testing, and then it'll go on to the IBM hardware testing. And all that passes, and it gets merged, and it's kind of official. So it's a very staged delivery for that process.
And at the end of the consumer postman where it builds it in the daily.
Yeah, then we
Places
get
it in the machine and then
an OP test
reports
framework.
bugs.
That's the holistic, the big picture at the end. I want to try to find as much as you can before it gets in, but then after it's in, this is the build that builds kind of the code after it's been merged. And so this is where you could point people last successful, which
That's right. Good.
yeah, and, you're
People
pretty
don't just
good.
run their entire firmware stacks as last successful build? Like,
Yeah.
is that just me?
Yeah.
Like,
Ship it.
What is stable build versus successful build? Is that both the same or?
Which one?
Stable versus successful?
Oh, that's just a Jenkins thing.
They're all the same.
Yeah.
In this case, it's the same, but what?
so Jenkins has the ability to say, like, you can have a successful build as in you compile it successfully, but you can then have other downstream builds that do a whole bunch of extra testing and mark one as stable. So you can say, like, okay, this one compiles, but this one is the one that actually passed all the tests. And so you can update that sort of as a cycle kind of thing.
Assuming you have a customized Jenkins.
Yeah, I see, yeah.
Yeah, we try and minimize that because
So you want to take like stable build, which has not been tested.
yeah. So it's one of the padlock. That's
Like in the magical future where everything is nice and it's integrated that does that.
That was one that I locked actually, because that was for the demos.
there used to be one lock that was the latest tag release, but Andrew removed it.
There is another Jenkins job that builds the latest
Yeah.
tags.
Oh, so I used to lock the latest tag on this, but it's not there anymore. Sorry, I just lost my Firefox window. Did a Firefox window pop up there? I just had the web UI and now it's gone.
These images are used by the Lina guys also to do the secret test for the CPU foundation. And they don't have, there's not so much images available on there. There's also Ubuntu Rock, which is using OpenBMC and its prototype to do non-migration of hardware monitors.
Yeah.
So it's starting to be used for other.
The domain's about to expire, so I'll pass my hat around. I've been registering the domain for the last 3 years. It's fine. Thank you to Rackspace for the free machine. We're going through Rackspace employees though. Like, do we have a contact there still?
Yeah, it's funny when it says down, right?
No, Addy's not there anymore.
Oh.
Yeah, that's what I mean. We're going through a.
Oh.
Yeah, you stole him. Maybe Facebook could donate a machine. Oh, when I change virtual windows, Firefox crashes. It's not my day. No, I'm VPNing in.
Oh, you're.
That's why my email started showing up on the screen. I didn't realize that was showing up there. Or maybe. Oh, it's just that it's full screen. There we go. Everyone look away. I'm typing in my password.
OpenBMC.
Dirty. Okay, so Andrew Jeffrey's been playing with this machine. So this is our web UI. We had an IBM design thinking session a couple of years ago, which is where you sit there and do post-it notes and talk about user stories, and I learnt all kinds of things that day. And then a team went away and did some design on this. So we had some proper designers kind of spend some time on the project and then implement it. They've now moved on, so it's kind of wholly owned now by the OpenBMC project. So any fixes we need to make, we need to work out how to make them ourselves. Have we done much work on the web UI since?
Yeah, I think the biggest thing's been new features coming in, like SMP, like you've got to add those in here. NTP stuff, console, yeah.
So this is the best thing ever. So
Joel, what are you logged into right now?
Australia. So this is a dev machine, a Romulus machine in our lab down in Australia. Yes, and this is showing us the SOL, the host console. So if I
Oh, good. It's 419 RC3 GCC78 stack random git commit. That's the best kernel.
yeah. So yeah, this is a latest and greatest. We're testing all the things Power 9 machine. So
This is running on the REST API, the Redfish, or like
no, this is the IBM REST.
The actual channel itself is just a WebSocket.
the SOA or
That'll be, serial.
Silo,
Yeah, serial channel is just a WebSocket. The browser running.
Yeah, all this stuff, all the sensors information is AJAX calls, so JavaScript calls to the REST API on the BMC.
Can you split the screen and SSH and bring it down off, sorry?
Yep. What? Go away.
SSH must be.
You're on ROM 1, not 2.
Thank you. Osram 2 wasn't turned on.
It's okay. Back home, everyone's gone to poll already, so we did power off the wrong machine. No one will really notice.
And then switch to the console on your other guy.
Is there a shortcut?
Down, just bottom one.
Oh, where? Sorry,
There it is.
I can't actually see from.
Down.
Oh, that one. Yep.
So those two should be shared, right?
Hey, system works.
So you can also connect over IPMI and also see the same thing as well.
Yeah, what else can we demo? So yeah, I was looking at the sensors before. So. So you can see all the sensor information and whatnot.
Well, you can run those fans pretty low, can't you?
Oh yeah, that's new. Or old. I think maybe this is an Andrew special. So this is running sensors and it's going and playing around with the HWM devices. It's the same information exposed over the REST API to the BMC web UI. So the BMC web UI it's an interesting architecture in that it doesn't need to be running on the BMC. So you can, I've actually got it hosted on my personal domain, and it makes HTTP connections, REST calls, to where the actual BMC is. And so the idea is if you had a bunch in your fleet, you could talk to all of them without loading up different versions of the UI. There was, I think, we spoke about in design of having it be able to collect the data from multiple BMCs in the one window. I don't think we got to that point in the implementation, but patch is welcome. And yeah, so at the moment we've just got the serial over LAN kind of console functionality, but there's a bunch of a whole bit of different parts that need to be done before we can get it working, but there'll soon be video as well. So you'll be able to, install your operating system. It's not as interesting for Linux, but if you're running operating systems that don't have a nice console installer, then maybe that's useful for you. Yeah, and that will be similar. That's Jeremy's been involved in some of that effort.
Yeah, so that's just a JavaScript NBD device, again running over what's happening.
NBD is network block device.
It's looking really good. It's close.
There's been a Linux thing forever. It's basically a simple TCP protocol doing block optimization. Oh, you get that.
So,
Oh,
So we don't have to exploit any of the network, it's just a local.
nice.
QEMU actually uses it as well. I
Yeah.
didn't know that until recently. You can have NBD devices. And,
You can do QEMU. We need to just set up like compressed QEMU things.
any other questions or points of discussion?
Yeah, if you have time, could you cover how you're organizing machines in the
In what, sorry?
how do you organize in the tree? How do you organize the various machines?
Right, this is definitely an Andrew question. A really brief overview is that there's different layers, different Yocto layers, and they're grouped by manufacturer of the machine, and below that are the actual platforms themselves.
Yeah, like, Facebook has a new layer they're putting their systems under. There's an IBM layer with the IBM system. There's also kind of tangential, there's an OpenPOWER layer, right, for anything specific to OpenPOWER that could apply to the other OpenPOWER systems. So, Meta Intel, they've got their own. So there's just a bunch of them. If you go up, anything with meta dash in the main directory, basically.
How recent did the Facebook go in?
What's that?
How recent did Facebook go in?
I don't even, Brad even merged it.
Oh, it's not in yet. Last week. As you can see here, we've got Meta Quanta, Meta Qualcomm, Meta Portwell. That's a machine. Why is that at the top level? Oh, they're the manufacturer, aren't they? Yeah. So yeah, these are all manufacturers here. Google, IBM, Ingresys, Intel, Invitec, ARM. It does get a bit confusing because Meta A-Speed's there. That's not a OpenBMC machine. That's the board layer for supporting A-Speeds.
And so when you look at the hierarchy, right, like the Witherspoon or the Romulus, is kind of your top layer. And then it says, okay, I want the OpenPOWER stuff, I want the A-Speed stuff, you kind of pull in the different pieces in your layers to build that system. And then there's a lot of open embedded layers you pull in as well to build the system. So it's going to need to see this grow. I think that's kind of the key part.
Does that answer your question?
Yeah, so it looks like there's been quite a few machines, Meta files added recently.
Mostly it was the restructuring. I think it made it more apparent as to where it all lived. Before it was they were deep in the hierarchy, whereas now they're merged into the top layer, I think. I think that was the big change. But yeah, progress is, we're moving along quickly. The Facebook additions, it's a big milestone actually, kind of the re-coming together of the projects, so that's good to see. And from the kernel side, I've now got consumers of the OpenBMC kernel in the UBMC. That's that Google project I was talking about. as well as OpenBMC, so that they've got some. They're asking questions about drivers and why have we enabled things like this and that, and so yeah, a bit of platform diversity there helps. More testing and more stuff going on.
So with all of the machine files there, do you think people are keeping those current? Or do you think they're still working off the private repo? Or?
I think there's still a lot of work going on behind the firewalls.
Yeah, there's still a lot of downstream only work happening.
We had a summit in January at Google's office in California, and there were lots of discussions between people planning on building machines there that hasn't eventuated any coded in the tree. I understand this stuff takes time. Like we first started talking to Facebook, we've been talking for a long time, but the intent to unify was about a year ago, and we're now only getting to the point where it makes sense to merge stuff in. So it'll take time. I think the important part is that progress is being made. If a vendor's talking about merging, but there's no code coming, then that's bad. But if we're talking about how to merge the code, then that's a positive. So we'll keep on pushing forward with that. It's hard to know how to encourage people to come out from behind their firewalls and get the code in if they're not already. I think probably most of the people in the room, the advantages are obvious, and you're only hurting yourself by not being in the tree. But maybe we need to make the benefits more apparent. I mean, I think the discussion about CI is a big one, because if you're in the upstream tree and something changes and breaks the build because your machine broke, then you're allowed to revert the patch. Whereas if you're merging that back in behind the firewall, then that's your problem. I know that Google have recently made a second push to try and get lots of their machines out. They were doing lots of development behind the firewall. Some of it's because different companies have their own secret source, but in this case it was just growing pains with the open source community, and how do we structure this? How do we get the code in? How do we share the maintainership roles? And I think we're making some good progress there with the Google machines.
Yeah, I'm just trying to understand how, if there's a machine file there, what's the relationship to the product that's actually shipping, and is there one, or can I go, reconstruct the binary from that meta file?
Yeah.
My suspicion is that anyway, the answer is no, because there's a lot of work that's done in the private repo, and ideally, at some point the answer would be yes, and then at that point when the answer is yes, how does it stay yes, so that throughout the life of the product that somebody can go back and recreate the image, or even if they can't even recreate that binary, can they create a binary that runs on that machine?
Yeah, it's a harder question to answer for the products that companies are actively creating OpenBMC for. For machines that it's kind of community effort supporting, so from Palmetto definitely falls in that category. I can tell you that Upstream Master works very well, and I've just spoken to someone who's grabbing it and using it completely independently on their machine, and it works for them. And so, yeah, the community-supported ones, I think we're going to have. There's demonstrated success already. For the machines that are products that companies are pushing towards, it's a bit harder. I know the IBM processes involve kind of forking off so that a stable release can be kind of verified and goes through internal tests before it goes out. So the thing, if you go buy whatever the IBM product number is, a Witherspoon, and look at what's loaded on your BMC, it's going to be really close to the upstream tree, but it's not exactly the same. And I think in this case, it's not that IBM's withholding any of it. All the code is more or less on the tree. It's more we're making sure it's stable, and that work to make the OpenBMC release process and release cycle follow the Octo. Maybe that'll help make the upstream more stable, in which case it will be easier for companies to ship a given upstream commit on their machine.
In our case, it's more to decouple the OpenBMC release cycle with the hardware
as a maintainer of part of OpenBMC, if one of my IBM colleagues came and said, can you please not merge those people's stuff because we're about to ship a product, I'd say, sorry, no. The open source project wins, and people are probably going to have to create some kind of stable branches. Now, if we can do that in the public project, that then people base their released firmware on a stable branch in the public product, that would be the best of both worlds, I think. Stuart's giving a talk tomorrow about the OpenPOWER firmware, and the parts of the OpenPOWER firmware that our team maintains down in Australia, you certainly can, you certainly should be able to find the commits in the upstream tree. We do our best to get all the code that's going to ship in the product in the upstream tree and kind of maintain it like an open source project more than a...
For example, it doesn't have any internal bugs that aren't using upstream commit. So
Yeah. And I mean, that makes your life a bit easier as a developer, but it's also important because you never want to be given a customer case where their machine's backtracing and you don't know what source version that is. There's different considerations there. If you're a Facebook or a Google where you're releasing machines to your internal consumer, it's probably a bit easier to hold all the cards because it's behind the firewall. Where you're a company that's making products that you're then selling to someone, it's a little bit harder. But we'll do our best, I think.
we should probably break for lunch.
Yeah, that'd be great.
So